This is a story of a plant that quietly takes out its neighbors, not with shade, not with crowding, but with chemistry. Released from the roots, drifting through the soil, reaching other plants from up to 50 feet away.
For decades, gardeners have blamed bad soil. They've blamed the weather. They've blamed themselves, pulling up tomatoes that wilted for no visible reason, replanting again the next spring, watching the same thing happen. They never suspected the tree at the edge of the yard. They never thought to look at the rye cover crop they'd just tilled in. They never imagined that the most beautiful plant in their garden, the one with the golden head following the sun, was rewriting the rules of who gets to grow beneath it. But the plants knew, they've always known. What we call gardening, what we call a peaceful backyard, is actually a 400 million-year-old chemical conversation happening in the soil right under our feet. Some plants speak softly, others speak loudly, and a handful, the ones we're about to meet, have evolved into something extraordinary. They use chemistry the way other species use thorns, or scent or color, as a tool to shape the world around them. Science has a name for this. It's called allelopathy. And once you understand it, you stop seeing your garden as a collection of plants. You start seeing it as a network where the most successful survivors aren't the biggest, or the prettiest, or the fastest growing. They're the ones who learned to communicate in chemistry, the ones we've been calling bullies, when really they might be the most intelligent organisms in the entire garden. This isn't a video about plants you should fear. This is a video about plants you've completely misunderstood. And by the end of it, you're going to want one of them on your side. To understand what's really happening down there, we have to start with the most famous example.
The plant that scientists studied first, the one that taught us it was even possible, the black walnut.
If you've ever lived near a mature walnut tree, you may have noticed something strange. Tomatoes planted within its drip line turn yellow and wilt. Potatoes refuse to thrive. Apple seedlings struggle to take root. Lilacs and rhododendrons collapse for no apparent reason. Meanwhile, the walnut itself stands there, healthy, productive, completely fine, as if the soil around it follows different rules. Because it does. The black walnut produces a compound called juglone. It's stored in the leaves, in the husks of the nuts, in the bark, and most importantly, in the roots. Every time it rains, juglone leaches into the surrounding soil. Every time a leaf falls and breaks down, it adds more. The tree is constantly, passively seasoning the earth around it with a substance that most other plants simply cannot tolerate. And here's where it gets remarkable. Juglone doesn't harm the walnut itself. The tree has evolved to be completely immune to its own chemistry. It's not poisoning the soil by accident. It's curating it. For a long time, gardeners thought this was just a quirk, a weird exception, one strange tree that you had to plant carefully around. Then researchers started looking at sunflowers, and rye, and sorghum, and black walnut suddenly had company, a lot of company, because allelopathy isn't a quirk, it's a strategy. And once you know what to look for, you realize it's happening everywhere, in forests, in cornfields, in your own backyard. Some of the most common plants on earth are doing exactly what the walnut does, quietly, continuously, and often completely unnoticed. So the real question isn't which plants are bullies. The real question is, why did so many of them evolve this in the first place?
The answer goes back 400 million years.
When plants first crawled out of the water and onto land, they faced a problem no animal ever has to solve. They couldn't move. They couldn't run from competition. They couldn't relocate to find better soil. Once a seed landed, that was it. That exact patch of earth was the only world that plant would ever know. And every drop of water, every speck of nitrogen, every photon of sunlight in that patch was something it would have to fight for, standing perfectly still for the rest of its life. So plants did something incredible. They evolved a language, not a language of words or sounds or movement, a language of molecules. Every plant on Earth releases chemicals into the air and into the soil. Thousands of them, constantly. Some of these chemicals attract pollinators. Some warn other plants when insects are attacking. Some call in beneficial fungi. And some, the allelopathic ones, send a very different kind of message to anything trying to grow too close. A message that essentially says, this space is taken. Scientists call these chemicals secondary metabolites. They are not used for the plant's own growth or survival in any direct way. They exist purely to shape the environment around it. Juglone in the walnut, sorghum in sorghum. Caffeine, actually, in coffee plants. Yes, the same caffeine in your morning cup evolved as an allelopathic compound to stop other plants from sprouting near coffee seeds. And here's the part that completely changes how you should think about your garden. Allelopathy isn't aggression. It's not anger. It's not even competition in the way we usually think of it. It's information. A plant releasing juglone or sorghum is broadcasting a signal, and any seed nearby gets to read that signal and decide whether to germinate or stay dormant. The seeds that do germinate near a strong allelopathic plant aren't being attacked. They're ignoring the warning. They evolved to handle that specific chemistry, the same way the walnut evolved to be immune to its own. So what looks like a one-sided fight is actually a conversation, a negotiation, a 400-million-year-old protocol where every plant in the soil is constantly asking every other plant, can we coexist here or not?
The bully isn't a bully. It's just the loudest voice in the room.
And once you understand that, once you stop trying to silence those voices and start listening to them, your entire approach to gardening changes.
So, who else is doing this? Start with the sunflower.
The cheerful, golden, child-friendly sunflower. Beneath every sunflower head is a network of roots leaking a cocktail of compounds, phenolic acids, terpenes, and others, that suppress the germination of almost every weed in the vicinity. Farmers in Eastern Europe figured this out generations ago. A field of sunflowers leaves behind soil that's noticeably cleaner of weeds for the next planting. The plant that follows the sun is also clearing the floor beneath it. Then there's rye. Common cereal rye, the same grain in your bread, is one of the most studied allelopathic plants on Earth. Its roots release a compound called DIBOA, which breaks down in the soil into BOA, a chemical so effective at suppressing weed seeds that it's been compared to a natural herbicide. When farmers grow rye over winter and chop it down in spring, the residue keeps suppressing weeds for weeks. It's not killing them, it's just refusing to let them start. Sorghum does something similar, but louder. Its roots release sorghum, a reddish, oily compound that you can actually see if you dig up a sorghum seedling and wash the roots. Sorghum blocks photosynthesis at the cellular level in nearby seedlings. The plant is essentially producing its own custom-built signal molecule, fine-tuned by evolution, that tells small competitors, you're not going to make it here. Eucalyptus does it from above. Its leaves, when they fall and decompose, release oils into the soil that few other plants can tolerate. This is why eucalyptus groves often have eerily bare ground beneath them, not just from shade, not just from dry conditions, but from chemistry written into every leaf the tree drops. And then, in the same family, there's the one you've probably never thought twice about, the common garlic mustard. An invasive plant in much of North America, garlic mustard releases compounds that disrupt the underground fungal networks, the mycorrhizae, that native trees depend on. It's not attacking the trees directly, it's cutting their phone lines. 5 plants, 5 completely different strategies. Suppression by roots, suppression by leaves, suppression by disruption of the fungal internet. And every one of them is operating quietly, continuously, in landscapes most people walk through without noticing. Now here's the part that changes everything. If you understand the language these plants are speaking, you can use it. For most of history, allelopathy was treated as a problem, a nuisance, something to plant around, to avoid, to design your garden in spite of. The walnut tree was the villain. The sunflower patch was a place where nothing else would grow. The rye field was something to till under and forget. But a quieter group of farmers and gardeners started asking a different question. Not how do we avoid these plants, but what if we use them on purpose? The first answer was cover cropping with rye. Plant it in autumn. Let it grow over winter. Then crimp it or chop it down before planting your vegetables in spring. The rye doesn't just protect the soil from erosion. It doesn't just add organic matter when it breaks down. It leaves behind a chemical signature that suppresses the germination of small seeded weeds, crabgrass, pigweed, lamb squatters, for 4 to 6 weeks afterward, long enough for your tomatoes, your squash, your peppers to get established without competition. Researchers at universities like Penn State and Cornell have documented this so thoroughly that organic farms across North America now use rye as one of their primary weed management tools. No herbicide, just a plant doing what it evolved to do, in service of the gardener who knows how to listen. Sorghum and Sudan grass can do the same job in warmer climates with a similar effect, sometimes even stronger. Mulches made from chopped sorghum residue have been shown in field trials to reduce weed emergence by more than 50% in some crops. And then there's the smartest move of all: companion planting with allelopathic intention. Sunflowers, planted as a border around a vegetable patch, can suppress weed pressure along the edges. Buckwheat, another mild allelopath, can be sown as a quick summer cover and turned into the soil to clean up a bed before the next crop. Even certain types of marigold release compounds in their roots that suppress not weeds, but nematodes, microscopic root pests that quietly damage tomato and potato roots underground. What every one of these techniques has in common is that the gardener stopped treating the plant as a threat and started treating it as a collaborator. The chemistry didn't change. The plant didn't change. The only thing that changed was the gardener's understanding of what was actually happening. And this is the real lesson hidden inside allelopathy. Not that some plants are dangerous, but that every plant in your garden is doing something more sophisticated than you ever realized. And the moment you start paying attention to it, the moment you stop fighting the chemistry and start working with it, you stop being a gardener who plants things.
You become a gardener who negotiates with them. Think about what we started with.
A tomato plant wilting near a walnut tree. A gardener blaming the soil, blaming the weather, blaming themselves. A plant standing 20 feet away, completely healthy, holding the answer the entire time. That tomato wasn't a victim of bad luck. It was caught in a conversation it couldn't read. The walnut wasn't being cruel. It was just doing what 400 million years of evolution had taught it to do, shaping the soil around itself the only way a plant that can't move ever could. Two living things, both following their nature, separated by a single piece of information the gardener didn't have. And that's the thing about allelopathy. It's not really a story about plants at all. It's a story about how much is happening in the world right in front of us that we never bother to look at. A patch of soil between two plants isn't empty space. It's an active conversation. A drift of leaves under a eucalyptus tree isn't just shade. It's a chemical signature being written slowly, season after season. Even the cup of coffee on your kitchen counter is a quiet echo of a tropical plant that figured out millions of years ago how to clear the ground around its seeds. Once you start seeing this, really seeing it, you can't unsee it. The garden gets louder, the forest gets stranger. The plants you walked past your entire life start to look like the most patient, most underestimated chemists on earth. So no, they're not bullies. They never were. They're just the ones who learned to speak the loudest language in the soil. And now that you know how to listen, you've got a choice. You can keep treating them as obstacles, or you can invite them in, learn their rules, and let them do for your garden what they've been doing for entire ecosystems for hundreds of millions of years. If this changed how you think about what's happening under your feet, you'll probably want to see the other half of the story, the plants that work together instead of apart, the ancient partnerships, the underground fungal networks that connect almost every plant on Earth. That video is linked on the screen now. Watch it next. Because once you understand allelopathy, the wood wide web is going to blow your mind. The garden is talking. It always has been. The question was never whether to listen.
If this helped, subscribe for more plant education, and I'll see you in the next one.